So we'll get started. My name is Robert. This is our talk here at SUSECon, from battle-proven to bleeding edge, how SUSE is about to improve the lives of developers. So an agenda, well, we'll go on to who we are, and we're going to talk about, is my software safe? We're also going to talk about why are we so concerned about security lately, right? What does this mean in the context of cloud native? I want to talk about how we solved it here at SUSE in a short demo, so it won't bore you to death. And then we'll talk about modern containerized applications and some next steps for everybody. So a little about who we are. This is me. I'm my Director of Technical Community Marketing here at SUSE. I'm an open source maintainer. I help with a project called Helm. I'm a CNCF ambassador, if that means anything, and I'm a wargaming nerd, so if anyone wants to talk about Warhammer 40K later, you can find me in the hall. I will talk for days about that. And I'm a dad of 2, so FX?
Yes, I'm François everywhere, but everyone calls me FX for obvious reasons. I'm product manager. I'm between SUSE Application Collection and BCI. I'm father of 2 as well, one of which is 6 months old, so I could not add any more hobby because I don't have any more hobby.
You don't have enough time in your life.
Exactly.
Real quick, so people understand, BCI real quick is base container images. So exactly. For anyone who's kind of questioning the acronym before we get started, we wanted to clarify that as we go. So we want to talk about, is my software safe, right? And this is a question that companies and individuals and people in the community have asked, and the answer simply is, it's never going to be safe. And we have to get it to a point where it can be as safe as possible. So why are we concerned about security lately? Well, these are some of the recent headlines I pulled over the past year. The SEC, for us in America, that's the Security and Exchange Commission, they're suing SolarWinds over the massive cyber attack, alleging fraud, right? We're beyond 2 years and Log4j is still haunting us, not only in the community, but companies as well. And another backdoor sneaks in with the XZ, that's how you say it, XZ, or XZ is how we say it in America, with this Linux package that compromises data. And so these are things that have been plaguing us, and they don't really go away, right? And it's kind of the crux of what we're trying to talk about here today. So what does this mean in the context of a community, right? Well, it's a loss of trust in any project. Any project that's out there in the open source ecosystem, people question whether they should use it. Is Log4j safe today? Maybe, maybe not. And who's out there, looking at it, as a community to make sure it's up to date? It puts a lot of existing pressure on maintainers because they do this for free, but it does put pressure on them because they don't want to see the project die. They don't want to see adoption go down, and they're stressed out to fix that. And it also detracts from contributions. I should know, because if you have any type of vulnerability, you have any bad press, the contributors just disappear. They go find new projects to go contribute to, and it's not sustainable long term. But what does this mean today in the cloud native concepts, right? Well, there's a bunch of things that we can talk about, but we're going to narrow it down to talk about these 3. Supply chain security, the OCI spec, and FIPS compliance. Hopefully everyone knows what those things mean. Do you want to speak to this one, Mr.?
I think it goes even worse when you think about it. There is a hidden spot when you talk about containers, because in the traditional legacy world, when you install an application, and as a developer you install application very often, you do zipper install, for example. And incidentally, it actually comes from your OS vendor repository. And it aligns with the build principle, security principle, express the commitment that the OS vendor is providing. When you do that in the container world, it's a little bit more complicated. When you do install a typical container, it's not just one application, it's actually a whole mini system that contains usually more than 40, 50 packages. And how do you keep track of that? How are you sure that the team that has built the containers that you have pulled have actually updated all of those internal components so that you can be sure that there is no vulnerability left? This is really what makes it complicated to keep track of what is happening when you are actually running on containers. It's difficult for the users, it's also very difficult for the developers. And in the context of maintaining trust or reinforcing trust, that is something to care about.
So what does this actually mean? Well, we have for multiple pipelines, we are building, scanning, updating, and maintaining. And this is a lot of work. It's not only for your development environment, your QA, your staging, your production. All of that has to be mimicked with different rules for each environment, right? And Francois will tell you, you forget the metadata. There's a lot of metadata that you have to understand, and it will be processed with that. So we had the same challenges as most organizations, right? And so how did we start to solve it? And if we looked at some of our applications, well, this is what we had. And especially when we acquire a company, we see this. We have multiple operating systems, multiple versions of operating systems, different configurations. Even with containerized applications, we looked at it. But with our base container was something that we figured we can address, right? So we are known for a few operating systems. I don't know if anyone knows this, but we Leap, Tumbleweed, Leap Micro, and even SLES. So we have a background in a few in the space when it comes to containers and operating system. But what we did was we created our own base container images, right? But we don't want you to. You can, but does it drive business value? Does it increase productivity of your developers? It actually detracts from those things, and we wanted to do it. So as we built them, we want you to use them, and we did that with a very permissible EULA that I know he can speak to a little more than I can. So these are the foundations of SLE BCI. SLE stands for SUSE Linux Enterprise. BCI stands for Base Container Images. I mentioned that earlier because we have a lot of acronyms. We're a tech company, and we love our acronyms. And SLE, some of these foundations, we brought in tooling where you can create and customize your own container images based on SLE BCI. We're multiple architectures with Arch 64, x86, PPC, and S390, or 390X, excuse me. Our EULA is very permissible, meaning that you can pretty much do what you want with an asterisk there. There is an asterisk, go ahead. I know you have it.
No, but of course, you are allowed to redistribute it. That's the main important part. As a developer, you can build something on SLE BCI and add anything you want inside that and then redistribute it, even in a commercial context.
So if you build it for your customers, you can redistribute it. You heard it here first. Stability. This is containerized SUSE Linux Enterprise application. Security audited and built with a third trusted party certified way. This is all done the same way we do SLES, right? And we have support options if you need it. Not saying you might need it, you could, but if you do need it, we're there for you. So we have different types of base container images. We have general container images. These are our NITs, our minimals, our busybox, and a few more. I think the version has gone up. I think it's SP7 right now.
6 and soon 7.
6 and 7, but 5 is still supported. Mm-hmm. We have development in containers. Now, this is the interesting part, that with our development containers, we have both runtime and an SDK, meaning if you're using the OpenJDK SDK, you can sit and develop with it and use that as your development engine. So if you have VS Code, I did a talk about this last year, you can actually use that as your SDK, and it builds, runs everything with inside the container, and if you know it runs, it works, then you can deploy it with the same runtime that we've built. So it's kind of in parity where you have a container where you can build out of, and the same exact container pared down to only thing you need for runtime is right there. So no more, well, it works on my machine. You can ensure that it's going to work. We just pare it down for you. And then we have some application containers like SLE with MariaDB, Nginx, PostgreSQL, and I believe it's 16 now. I should have updated that. We have our own registry. You can go out there right now and you can go search it, pull from it. I do this quite frequently. This is where I figured if SUSE is, if it's good enough for SUSE customers when we deliver some of our products, it's good enough for me to do it, and you can go check it out. We're also available on Artifact Hub. So if you can't get the SUSE registry, but you can get the Artifact Hub, we upload them there as well. So they're all up and to date. Some other features. We have automatic updates for when we found vulnerabilities. So the packages are continuously scanned and the container images are continuously rebuilt as we find vulnerabilities. So what you get one day might be updated the next. What you got an hour prior might be updated because we're consistently updating them for security. We have compromised documentation. I can tell you that because when I read it and I don't understand something, I go find somebody at SUSE and go yell at them because it does not work. So it is very comprehensive because I do use it quite frequently. We do have an active community of users. I run the community team here at SUSE. We have a channel. People are in there. They're asking questions. They're using us. And extensions are available with some of the sleeve subscriptions, but that's only with the subscription. So if you're a customer, this is an option that you have. And all of our containers are tested prior to release on other host operating systems. So we're not like, oh, it just works on our operating system. We don't know what happened when it goes to any others. We do it on multiple. And we do it on also Docker, Podman, and Containerd. The Sleep PCI compliance and traceability, we are 6-door, notary signature, salsa providence, SBOM. We are FIPS 142 and 143. That's provisional, the 143, because I know they've changed the standards once again. So don't quote me on that's being provisional. The rules of that are changing as we speak, but we are focused on making there. And the Sleep BCIs are within the Iron Bank. So if anyone's on FedRAMP space, you know what that is the U.S. government's like central repository that where they put their. So where are we using it? Well, we're using it in Rancher and SUSE Rancher Prime. NuVector has our container images as well, and that's part of SUSE Security. SUSE Multi-Linux Manager and Uni all use this. Trento, which is our product for some of the SAP deployments, all use it. And we also use it in our SUSE application collection. FX is one of the product, you're the only product manager of that. That's right, I thought it was two of you. You own it all right now. And this is free access to all Sleep BCI containers that you can use, and we want you to, right? We want you to stay secure out there. The internet's a dangerous place. Now, if you don't believe me it's dangerous, I actually have a demo. Let's see if it works. So with this one here, I went to Docker, and I pulled from our registry. I said, give me a Python image. I wanted to pull it down, and then use Trivy to look at it. Scan for vulnerabilities. Now, while that's going, if anyone has any questions, you will not interrupt my flow here. If you guys have questions, feel free to ask.
So on your unit question, the statement, so you can run your images on Red Hats or anything like that?
Yeah, we don't care.
No licensing?
Yeah, the BCI, if you want to talk about the business model we have for BCI, it's part of SLES. So if you have a SLES subscription, you get the support, which is what we sell for SLES, on BCI. But if you do not need support, it's available. You can use it, you can redistribute it. You just cannot install all the packages that are part of SLES that are from very specific use cases because we need to control some aspects. But you can do pretty much whatever you want. It's serviced on SLES host. It's free for every use case, besides being serviced.
So that's a great question, by the way. I'm using Trivy here, and I'm asking it to, find any vulnerabilities of high and critical. I want to make sure, like, we won't do all of them because there's going to be a lot of noise. There's some informational ones that are there, and the reason I had to do informational ones, I'll get to towards the end of the demo. And this, when I ran it, this is what we found: just a few informational, one warn, and that was it. But when we go over and we do it for the Docker one. Google Slides.
Sorry?
It's just so slow.
Yeah, I agree.
This is
there's
really.
No other question?
Yeah, there's. So we're going to do it for the Python one that I pulled from Docker, and the reason I had to go to critical and severe, or high and critical, is because there were so many when we saw it. And it took about 12 seconds, and this one here found 38 vulnerabilities in that package. So just by pulling from Docker Hub, and we keep ours updated for that reason. All right, so what about modern containerized workloads, right?
When it comes to what we call modern containerized workload in this context, which be basically Kubernetes, You can start with the container challenge that we just saw, like the high number of vulnerability and the fact that this container space is very much developer-driven, and so instead of relying on an OS vendor, you rely on a community, and in Docker Hub, for example, pretty much everything can happen. So you take this challenge and you make it 10 times bigger. Why? Because when you consume an open source application for Kubernetes, you usually use something like a helm chart. And these helm charts may refer to subcharts. And those subcharts may in their own turn refer to several containers. And they may not have the same source, they may not have the same principle. Having guarantee that you are not going to pull something that you cannot control, having the guarantee that you are not pulling thousands of CVE is tough to do. So that's what I call the modern containerized workload challenge, 10 times bigger than just for one container. But it doesn't end here. If you are working on a typical Kubernetes application, usually you do not just pull one open source component. For example, you may need an API gateway, you need a web server, you need a data stream, you need database, identity provider, whatever. All of them are bringing this kind of risk. And if they come from different sources, and if you just do, if you just go on Docker Hub or Artifact Hub, they may come from different sources. It's really, once again, it's a Far West. So that's why we really needed to come up with something. And I really want to give a concrete example. This is an application quite popular. It's an API gateway. It's called Apache API6, so it's part of Apache Foundation. And I really appreciate talking about this one because it's not just anything out there. There is actually a company behind Apache API6 called API7, and they actually provide a helm chart, an official helm chart, for installation of their product. As you see, this is a rather complex application. It's not exceptionally complex, but it's rather complex. You have 4 helm charts, the main one, and it pulls 3 subcharts. And each of those helm charts pull 1 container. Well, if you look at this, there is one square at the right hand of the drawing. It's etcd, because the helm chart that you are actually pulling when you are using Apache API6 with the official helm chart, it's not a helm chart that has been developed by the company behind the rest. It's the Bitnami one, because it was available, it's convenient, and it's open source, it's all about reusability. So it just does make sense. But it means that you're going to have 2 different implementation approach for the helm charts. So you already start with heterogeneity, which is increasing the difficulty to make it in control. And you happen to have 3 different underlying base operating system. etcd is based on Debian 12 base image. Apache API6 is on Debian 11, and the dashboard, for some reason, is based on Alpine Linux. And if you start to look at the CVEs for this whole picture, 396. It's something you can check yourself. It's based on, it's available on Artifact Hub. So you go on Artifact Hub, and on Artifact Hub you have this feature, security report. As a publisher of content on Artifact Hub, you can choose to remove, to hide the security report. But for API7, it's present. So you can see 396 vulnerability found as of today, including 16 critical for one application. And this application is an API gateway. It's not meant to run as itself. It's meant to run together with a web server, an identity provider, etc., etc. So you start to see how risky it is and why we need to come up with something. But that's not just it. You can maybe, thank you. What if a malicious hacker compromised the supply chain? So Robert just showed you before the headlines about security. One of them was SolarWind. SolarWind was a Russian hack, and they had compromised the build pipeline of a company, which means that the developer were developing and committing their changes, no problem. And then the customer were getting their patched version, no problem, but in between, there was a hack, and there was some malicious code injected. What happens if one of those containers had some malicious code? You see based on that, there is no guarantee of who is owning, you don't have any contract with anyone building those containers. So it's really, really risky. And you see, we have our own approach to that. And our approach is pretty simple. We do everything from the ground up. We start with the base image. Of course, we use the base image that Robert had talked about, which are the SlibCI micro base image. It is our smallest footprint base image, so it's really meant for runtime on production. So we start with this one. It's super secure. It comes up out of our SALSA level 3 build pipeline, so it's the highest level in SALSA For those who don't know SALSA, it's secure supply chain level for software artifact framework. It was initiated by Google. It's now quite a popular open source framework, and the highest level is 3. And it means that everything you build is built in an isolated, ephemeral, scripted environment. Everything is traced, everything is signed, and that's what we do. Now, I like to say that compilation is basically source code laundry. You see what's coming inside. The source code is human readable, but what you get outside, it's binary. It's not human readable anymore. So you need to build the trust on whatever is doing the compilation. So it starts with the compiler, but that's the whole build pipeline. You need to trust this build pipeline, and SALSA is a framework that describes what are the best practices so that you can trust this build pipeline. The fact that it hasn't been tampered with by hackers, for example, the fact that you have traceability, the fact that you can map every binary with a source code that is notarized. This is what we do. We do that with, as I told you, we do that with the base image, but we also do that with every dependency that we need to install the flagship application and the container. So if your container has 50 packages, the 50 packages come from our build pipeline, and you have all the metadata to demonstrate everything. You have all the licenses that are listed in those metadata in the software bill of material. You have all you need for traceability, for automation of security policy, etc. And it starts with containers. It goes up to the Helm charts, and even in this context, because we have subcharts, the main Helm chart. Everything built by us. Everything is automatically updated. So whenever there is one dependency where there is a new release from upstream, because there is a CV, for example, that has been patched, we rebuild everything that requires this dependency.
Not just the single one that you found. It's just we rebuild it. We just kick it off and we do all the builds.
Exactly. It's a transitive approach. So no matter where the binary is in your stack, if there is a new version that solves the CV, we are rebuilding everything that needs this binary. So every application, everything, and every Helm chart. So you end up with one single trusted source. Everything is built on one single source-based OS. It's consistent across all our 70 applications. And of course, this is a lie. It's 72 because we're growing very fast. Last month it was 60. It's growing fast. And the result, you see it by yourself. It's 11 CVE. You can come to the booth. We are demonstrating that. We really go from 396 CVE to 11, and 0 of them are critical. All of that without changing the source code, just by applying the best practices in terms of building and updating every dependency. And we do that automatically all the time.
Yeah.
So what does it look like? It looks like that. So this is the web page it's not the right title. It's called SUSE Application Collection now. Sorry about that. So you have this web page that you can see is open. You can see the content. The content actually is behind paywall. So if you want to download it, if you want to install it in your system, you have to be a Rancher Prime customer. Or now, we are advanced that today, it's available on AWS as well. But exploring the collection and see what it has and see the metadata is something you can do for free through the web apps that you see here. And maybe, if you want, I can show you what it looks like. I think we have a little bit of time. Yeah. So we start with this main page, we just saw. And in this main page, you see the latest edition. And you can also get an Atom feed. So if you want to subscribe and be informed every time there is something new, you can. We have the Atom feed. We have the history of releases. And that's super interesting because you really get to see how much content we are adding and how fast it goes. And you can check all the history. We are very transparent on that. You can search and filter through the collection, of course. So you can search by name. You can filter if it's a Helm chart or a container, or you can filter by category of application. You can see all the branches of one application. Our policy is that every time we build every releases that are supported by upstream. So of course, upstream open source project, as you all know, they have a set of versions that they take care about, and if there is a CV found for those, they're going to solve the problem, but at some point we start drop the old version. So we just replicate what upstream does. And because it's all automated and updated, you already have the freshest version in a matter of hours. So if you want to deep dive, for a given release of a branch, you can see all the elements of the in-toto attestation. In-toto attestation, it's a bundle of metadata that goes with an artifact that is built. So here you see you have the SBOM, the software bill of material, in two formats, CycloneDX and SPDX. Those are the two formats that are recognized by the US federal government through the Secure Software Development Framework that is not mandatory. If you want to sell anything or deploy anything to the federal government or any of the federal agencies, you have to have at least one of those. We provide both, so you can have all of them. SALSA, so we are talking to you about the framework. It also goes with a set of metadata, the SALSA provenance. We have vulnerability scanning. It's automated. We do it frequently, depending on the age of the artifact, by the way. So we do the scanning with Trivy, which is the most popular, and we just use it. Robert just show you the Trivy scan for a container. So we use that. We also use New Vector, which is the project behind SUSE Security, because of course, we drink our champagne. And we have a ClaimAV antivirus scan. You get all those results signed, available through the user interface. We also have a REST API to get them. You will also have them, of course, as artifacts from Sigstore. So you have all you need to see what's inside and feed whichever system you want for automation, for traceability, for notarization, etc. And of course, we also have vulnerability scanning, and we show the vulnerability in a very transparent way. We also show you all the system packages that are included. And we did not just limit ourselves to tell you what application and what version. We also told you about the license. License is super important in enterprise environments. You want to ensure that whichever constraint you have from a license standpoint, you are following those constraints. By providing use this information in a visual way, but also in JSON file because it's part of the SBOM, we really enable our customers to control what they are dealing with and add the policy and automation that protect them. And one thing that is quite unique, I think, we now have the feature of comparison of two versions of a given artifact. So if you pick one version and you want to understand why is it that we triggered the rebuild, you can just pick another version of the same artifact and you see why it is. And this one I like because it's Apache TK, and you see we have rebuilt it. We're comparing two versions. And the only difference is the system packages, libx11.6, libx11 data, and OpenJDK. So we did trigger the rebuild, even if the flagship application, Apache TK, stayed the same. It's really a demonstration of this principle. And this is how we keep the application safe. Next steps?
You can start using Sleep BCI today, right? You can go out there to suse.com/products/space container managers. You can find out more. You can link to the documentations. If you're part of our community around K8's projects, you can please feel free to reach out. We have a Slack channel for it. If you're part of a company and they ask them, do they maintain their own securities and ask them why they're not, how do they maintain securities on an OpenStack applications?
Just want to double down on that. At SUSE, it's been our raison d'etre since 25 years to uplift the open source ecosystem to enterprise-grade consumption. In Kubernetes, it's an even higher challenge. This is what we try to demonstrate today. It's not a matter just of selling or anything. It's also a matter of security of your organization. That's something worth looking at. Where do you source your open source application for Kubernetes is super important. And you should really ensure that you're being on the safe side.
Okay, well, all right. Well, thank you guys.
Thank you.
We're done.